everyone. Today's recording, I'm using a background music. I learned from another math teacher, Miss Suman. So she said when she does recording, she play this kind of meditation music in the background. She feels more relaxed. So I think we're going to give it a try. I hope you like it. If you don't, you could privately let me know. All right, let's start. So this is a 1.4 geometric series. That means add them together, so sum. All right, now this one, the deriving the formula. Now please take a look by yourself. This is pretty much easy to understand, so I don't think that I wanted to spend time here to go through this. All right. Now note these kind of way of doing things. Now, for example, you write the sum as all these terms are together, and then you multiply this, the negative common ratio on the left hand side. So then you multiply them by every single term by the negative common ratio, and then you add them together. You add this side together because the point of the matter is to cancel. You see, cancel all the terms so that you only have this term, the first term, and your last term left. All right, so this is not even the last term. This is basically the term after your last term. This is in your series, in your sequence. This is your last term. So you multiply by another common ratio, you get another term. This is a further one thing down the list. And then you can derive the formula. Now, this kind of thing is all called algebraic manipulation. And it's very important in terms for proving, or in terms for, even coming up, proving is they already came up with this formula. Now we're only trying to understand why the formula works this way. But when whoever is the first mathematician deriving the formula, this is a manipulation they need to do. So the better you're at this, the more ability that you would accumulate for yourself in terms of problem solving using called mathematical manipulation. So now this is the formula of the sum. I always just use this one. I find this one is easier to remember, very simplistic. This is the first term. This is the 1 subtract the common ratio, and depends on how many terms is here, and the bottom divided by 1 subtract the common ratio. I just always use this one. All right, so now these questions very straightforward, and now please study for yourself. I basically wanted to demonstrate 2 examples here in your textbook, and also want to do a 1 question in the exercise set. So now this is the first one. The first one is, the interesting is we needed to get used to, this is called a summation notation, right? So this guy, or this whole thing. Okay, so it says find the sum. So then this is 3, negative 2, and k minus 1. All right, so basically each one of them, each ak is this value. So the way that I did was that I'm just going to see what is the first term. Okay, now what is the first term? A1, so that means the k equals to 1. So that means 3 and the negative 2 to the power of 1 subtract 1. So then that becomes 0, and 0, this becomes 1. So A1, as a matter of fact, is just 3. Okay, now how about what is my A2? Okay, A2 equals to 3 and negative 2 to 2 minus 1. So therefore, this one is 3 multiplied by negative 2. Now, of course, your R is A2 over A1. Then very easy to see this is just negative 2 because it is 3 negative 2. Therefore, I don't even multiply it out because I know that divided by 3, this would just cancel. So there's no point to multiply that out, become a negative 6. It's absolutely unnecessary work. So then that is just negative 2. So my R is negative 2. So then therefore, I'm just going to use the formula as n. As a matter of fact, now it's from 1 to 10. So it is 10 terms add together that equals to the first one, A1, this 10 divided by 1, that. Then I know my R, I know my A1, so then this is no problem. Okay, so then that is 3 and 1 subtract to the negative 2 to the power of 10. That is just basically 2 to the power of 10. So 2 to the power of 10. As a matter of fact, anybody would love to learn computing science, and probably some of you already studied at Lord Bing for the computing science courses. Now you all know this is equals to 1024. Right? So this is all equals to 1024. So then that means 3, this negative positive is the same thing. So that means 1024 and divided by 1 subtract negative 2. And you're just going to calculate this. So 3 multiplied by negative 1023 divided by 3. All right, so then this is just the way to find the sum. But just get used to this type of writing. And to me, I would just always wanted to figure out what is the first term and then figure out what R is by getting the second term. And then the rest will be very easy. Now this one, please note. So we talked about, so this one. So we talked about that if each term that is a linear function, then this is arithmetic series. And look at this. This is not a linear, but this is, as a matter of fact, it's called a power function. Okay, power function. So if it's a power function, then that is a geometric series. But however, if none of them is not a linear, not a power, then that means it's neither an arithmetic or geometric series. Okay. Now this question I find interesting. So this is says write the geometric series using the sigma notation. Okay. So now we have 1, 2, 3, 4, 5 terms here. And then the first term, the second term, of course, from the first term to the second term, the R equals to first term, second term divided by first term. So that is 18 divided by 6, then that is 3. So good. So my R is 3, and then my A1 is 6, right? So then in terms of this, my sigma notation, then therefore should be K is from 1 to 5, because of 5 terms altogether. and then equals to my first term, which is 6, and then multiply by ratio, common ratio, which is 3, and then it's n minus 1. So that means the k minus 1. Right? So that is my an. So that's k minus 1. So then if you test this, of course, when k equals to 1, then that's 0. So this is 1. And then if the first term is 6. But we could also revise the way to write this. The reason why is because within the 6, there is a factor of 3. So we can also break this into 2 multiplied by 3, multiplied by 3, k minus 1. Now therefore, this becomes 2 and 1 plus k minus 1 becomes k. So then the sigma notation is looking like that. And then done. Okay, now last question, last example I want to demonstrate is in the question down here. This is a very typical question about geometric theory series. Now question number 19. Okay, so it says a ball bounces up 3/4 of the distance from where it falls. How far does the ball travel in total after hitting the floor the 4th time if it dropped from 36 feet? So basically, so this ball is here, dropped, right? Dropped. So then this distance here is 36 feet. And then the ball will bounce back. Bounce back. The distance from here to here now is 36 multiplied by 3 over 4 because it's bounced back 3/4, right? So then it goes down again and it bounces back again. It goes down. So it's going shorter and shorter and shorter. All right? So then what's going on here is this is the first time they hit the floor. This is the second time it hit the floor. This is the third time it hit the floor. And this is the 4th time it hit the floor. All right? So it says the total distance. So here, 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 here. Total distance. Okay, so how can we do this? What will be the easier way to think of this? So then I can rewrite this diagram into this. How about I do this? So I add on this side. So this is 1, this is 2, this is 3, this is 4. So there's 4 loops here that I'm going to add it together. However, I am just going to subtract the first because we don't have the first. We did not throw this ball to the top and then let it bounce. We basically drop the ball, you see? It says it bounces up from where it falls. So it says 3 fall. So this is drop and then bounce. So then if this kind of loop, we can use the geometric series to do it because each one of them is going shorter by 3 1/4. All right? So that means my A1, the total is 36 multiplied by 2, right? 36 multiplied by 2 is 72. And then what is my R? My R is shrink 3/4, right? And then how many of these total here? There's a 4, so n equals to 4. Okay, now follow the formula. That is the total, the S4 now equals to 72, 1, subtract. Be careful, this is a fraction, this has needed to have a bracket to the power of 4 and then divided by 1 subtract 3 over 4. So after you calculate this though, because asking the total distance, total travel, this should have no this part. Therefore, the total, should you use my S4, subtract 36. And then that is the total distance traveled. All right.